So let's start, huh? So just a second. चलिए, ओके. सो बेसिकली वी वर डिस्कसिंग पावर सीरीज, करेक्ट ना? लास्ट क्लास में हम लोग पावर सीरीज कंसिडर कर रहे थे. We were discussing power series. We have taken sufficient examples. So let's take few more examples on the power series. Then we will take examples on. Then we will take questions on functions of one variable. ठीक है? Okay. चलिए. So like I am considering a power series question. Okay. So I am considering a power series a n x raised to n square, where ans are defined by n factorial upon 2 raised to n into 3 raised to n. Okay, we need to find here r, that is radius of convergence, and exact region of absolutely and uniform convergence. Okay, we will find here region of absolutely and uniform convergence. We know all very well that there is exact region of convergence. By the meaning of exactness, if we are getting bounded region, so exactness का मतलब है we are including the boundary points. Exact region of absolutely convergence, that means we are including the boundary points, and exact region of like uniform convergence or same as convergence, also the same meaning, we are including the boundary points. Correct na? Chaliye, okay. So look, as I am having here x to the power n square, correct na? So to find the radius, I need to use here singleton formula. As singleton formula will work for every power series. Okay? Every power series, like, okay. So the radius is nothing but 1 upon limit n tending to infinity mod of a n raised to 1 upon the power of x minus x naught, that is which is n square. So 1 upon limit n tending to infinity, an is what? N factorial upon 2 raised to n into 3 raised to n, and it's a positive number, so no need to put it in modulus. So to the whole square, whole power is 1 by n. So the limit n tending to infinity, what I will have basically 2.3 to the power 1 by n. Yes or no? Correct na? N to n goes cancel out. So 1 by n I will have, and in the denominator I will have n factorial raised to 1 by n square. Okay. So here I can apply the algebra, as I can take limit of numerator and denominator separately. I can take limit of numerator and denominator separately. So what will be the limit of numerator? Limit n tending to infinity of 6 to the power 1 by n, and denominator limit n tending to infinity n factorial to the power 1 by n square. Clearly my numerator limit is 1. I need to find that denominator limit. How we will find the denominator limit? How we will find this limit? किस तरीके से हम लोग ये लिमिट फाइंड करेंगे? Very nice, Pratiksha, by using the sandwich. Yes, we have practiced such questions. ठीक है? Yes, as we know the estimation for n square. Sorry, not n square. We know the estimations for factorials. As we know, factorial n factorial is less than equal to n raised to n and greater than equal to 2 raised to n minus 1 for every n. Okay, it's a very nice. Yes, very good, beta. Okay, so I can take positive power 1 by n square in this inequality. So 2 raised to n minus 1 upon n square is less than equal to n factorial to the power 1 by n square is less than equal to n raised to 1 by n. Okay, so look at it. Look at here. This is nothing but 1 plus 1 by retain n and simplify the power. So I will have 1 minus 1 by n upon n less than equal to n factorial raised to 1 by n square less than equal to, it is same as 1 by n, like ठीक है, n by n, so 1 by n. Okay, now n tending to infinity, this tending to 1, n tending to infinity, this tending to 1. So by the sandwich theorem, this middle term also tends to 1 as n tending to infinity. Correct? So here my numerator limit is 1, denominator limit is 1, so overall value of limit is 1. So here radius of convergence of this power series is 1. ठीक है जी. Okay, so now what will be the reason? Here the reason of convergence as well as uniform convergence as well as absolute convergence is mod of x is less than 1. But if I am talking about the exact reason, that means I need to check convergence and absolute convergence at the boundary points. Correct है? यही मतलब है exactness का. So x belonging to -1 to 1. I need to check at both the boundary point at x equal to say -1. So at this point my series will become like n factorial upon 2 raised to n, 3 raised to n, n factorial upon 2 raised to n into 3 raised to n and -1 to the n square. ठीक है? As n square of odd number is odd, square of even number is even. Yes, even number square is an even number, odd number square is an odd number. So this is going to be what? An alternating series, na? It is nothing but an alternating series. हाँ जी भाई, करेक्ट बात है ना? चलिए, ऑल्टरनेटिंग सीरीज का कन्वर्जेंस. इफ आई एम टॉकिंग अबाउट ओनली कन्वर्जेंस मीनिंग सेम एज यूनिफॉर्म कन्वर्जेंस. ठीक है? सो आई विल अप्लाई हियर लेबनीज रूल. ओके, सो लेबनीज रूल अगर हम अप्लाई कर रहे हैं तो un हम लोगों को मान लेना है यहाँ पर n फैक्टोरियल अपॉन 2 रेज टू n इंटू 3 रेज टू n. डज इट इज डिक्रीजिंग? डज दिस टर्म इज डिक्रीजिंग? Take n plus 1 un plus 1 minus un, that is n plus 1 factorial upon 2 raised to n plus 1 into 3 raised to n plus 1 minus n factorial 2 raised to n into 3 raised to n. So I can take this complete term outside, n factorial upon 2 raised to n into 3 raised to n. Here I will have n plus 1 divided by 6 और minus का 1. ठीक है जी. So the thing is, this term is positive. So this term is positive, and inside it I will have n minus 5 divided by 6. Correct है जी भाई? Yes. So what I will have, this going to be greater than 0 for all n greater than 5. Yes na? Yes or no? un plus 1 minus un. Okay. Yes. Yes. So I can say this is decreasing. Yes, this is decreasing for all n. After removing first term, it is decreasing. So my work is done. ठीक है? Now I need to find limit also. I need to find limit of this term also. अच्छा जी, okay. Can anybody tell me how to find limit of this nth term? n factorial upon 2 raised to n into 3 raised to n. We need to find this limit. हाँ जी. So how we will find this limit? रेशियो से, रेशियो विल वर्क. लेट्स हैव अ लुक. ठीक है? तो टेक un plus 1 upon un. तो n plus 1 factorial upon 2 raised to n plus 1 into 3 raised to n plus 1 into n factorial 2 raised to n 3 raised to n. ठीक है जी. So I am just having n plus 1. ठीक है, divided by 6. So this will tends to what? Infinity. Yes. So here ratio's limit is what? Infinity. Ratio's limit is what? Infinity. That means much greater than 1. So this will implies limit n tending to infinity of nth term will be what? क्या होगा? I am applying here ratio's limit. If my ratio's limit is greater than 1, sequence will tends to infinity. If ratio's limit lies between -1 and 1, then sequence tends to 0. Correct now? Correct? Yes. So here limit going to be what? Infinity. So as nth term limit not equal to 0, so this will implies my alternating series is not convergent. So this will implies alternating series is not convergent. Not convergent, it will be oscillating. If alternating series not convergent, it will be oscillating. ठीक बात है? चलिए. So at -1 my series is not convergent. If my series is not convergent, then I will if series is not convergent, तो it cannot converge absolutely ना. सीरीज अगर कन्वर्जेंट ही नहीं है तो एब्सोल्युटली कन्वर्जेंट तो बिल्कुल भी नहीं होगी. सही बात है ना? ओके. इसी तरीके से अगर आपने +1 पे देखा तो +1 पे यस ऑसिलेटेड. तो +1 पे क्या रहेगा? at x is equal to plus 1. Series is nothing but n factorial upon 2 raised to n into 3 raised to n. ठीक बात है. Clearly divergent. Reason, as limit n tending to infinity of nth term is equal to infinity, not equal to 0. If nth term limit not equal to 0, series will not convergent. And I am having here positive term series which is not convergent, implies series is divergent. Correct? Okay. So at plus minus 1 my series is not convergent, so it never going to be converged. Absolutely convergent ही नहीं है, तो absolutely convergent तो बिल्कुल भी नहीं रहेगी. सही बात है. So this will implies here exact reason of uniform convergence and absolute convergence is nothing but open interval minus 1 to 1. Clear to everyone? Sure. Let's take another question quickly. So next question, I am considering a power series an x raised to n square, ठीक है, and running from 0 to infinity, and here the coefficients ans are defined by the recurrence relation. Ans are defined by the recurrence relations as a naught is equal to 1 and an is equal to 2 to the power minus n into an minus का 1. ओके जिनेश मैम, आपको क्वेश्चन बैंक मिला हमने. जिनेश बेटा, क्या मैं फ्री बैठी हूँ क्या? हाँ जिनेश, आपने क्वेश्चन बैंक सेंड किया बेटा. क्या वो रियली पॉसिबल है मेरे लिए कि पूरे के पूरे क्वेश्चन बैंक का सॉल्यूशन आपको सेंड कर सकूं? बेटा डाउट पूछा करो. इस टाइम पीरियड में कितने सारे बच्चों के डाउट्स रहते हैं हमारे पास. बेटा वो डाउट नहीं है, वो तो आपने पूरा का पूरा भेज दिया भाई. उसमें से कुछ सिलेक्टिव क्वेश्चन जैसे कि प्रांशु ने सेंड किए थे, तो प्रांशु के क्वेश्चन पर 5-6 क्वेश्चन प्रांशु ने सेंड किए थे, तो मैंने सॉल्यूशन सेंड कर दिया है उसको. तो उसमें से कुछ सिलेक्टिव क्वेश्चन भेजो बेटा. क्या था वो? उसमें से कुछ सिलेक्टिव क्वेश्चन है, तो वो आप सेंड करो. ठीक है बेटा, चलिए ओके. सो ये मेरे पास सीरीज है वेयर a नॉट इज इक्वल टू 1 and an equal to 2 raised to minus n an minus 1 for all n greater than equal to 1. Okay, so here also we need to find r and exact reason of convergence, uniform convergence and absolutely convergence. ठीक है, I not get till now. Okay प्रांशु, एक्चुअली बेटा कल मैं सेंड करना भूल गई थी, तो आज मैंने उन्हें फॉरवर्ड किया है. सो सर विल सेंड यू सून. ठीक है, यू विल गेट योर क्वेश्चन सॉल्यूशन सून. ठीक है, ओके ठीक है. So whenever I have such kind of power series, but coefficients are defined by such recurrence relation. So we need to find a general term. We need to find a general term for the coefficient sequences, है ना, by observing the terms. Okay, so here a naught is equal to 1. a1 will be what? a1 will be 2 raised to minus का 1 और a naught. ठीक है जी. Okay, so 2 raised to minus का 1 into 1. Okay, so I just have here 1 by 2. I just have here 1 by 2. Yes, I think this question we have done. Yes, I think this question we have done. मुझे भी कुछ ऐसे लग रहा है. A2, as we are trying to find here a pattern between the terms, ना, between the terms. So no need to. So the thing is, keep your terms as it is. ठीक है, do not multiply and divide them. ठीक है, keep them as it is. Okay. ठीक है. So then let's do it quickly. Okay. ठीक है, फटाफट से कर लेते हैं फिर इनको. Okay बेटा, okay. So A2 will be what? A2 is 2 raised to minus का 2 and A1 that is 2 raised to minus का 2, 2 raised to minus का 1, which is same as 1 upon 2 raised to 2, 1 upon 2 and so on. So the thing is, nth term an will be what? 1 upon 2 raised to n, 2 raised to n minus 1, keep going like that, 2 raised to 2 into 2 raised to 1. So I'll just have 1 upon 2 raised to n into n plus 1 by 2. Correct है भाई? ठीक है जी? Okay. So it is my an. Basically the an is nothing but 1 upon 2 raised to n square by 2 into 2 raised to n by 2. ठीक है? It is my an. So the radius is nothing but 1 upon limit n tending to infinity mod of an 1 upon n square. That is 1 upon limit n tending to infinity 1 upon 2 raised to n square by 2 into 2 raised to n by 2, and the whole power is 1 by n square. Correct hai ji? So this will be in numerator now. So 2 raised to 1 by 2 and 2 raised to 1 by 2n. Correct hai? So n tending to infinity, this tending to 1. So I'll just have square root of 2. Yes, hanji. So radius is nothing but root 2. So my reason will be mod of x is less than root 2. That means x lies in the open interval minus root 2 to plus root 2. So we need to check at the boundary point only, because I need to find exact reason of convergence, exact reason of uniform convergence, and exact reason of absolute convergence. So we need to check the convergence as well as absolute convergence at the boundary point. So यहाँ पर हम ले लेते हैं at x is equal to minus का root 2. So at this point my series will be 1 upon 2 raised to n square by 2 into 2 raised to n by 2 into, instead of x I will put this. So minus of root 2 to the power n square. Correct? Instead of x. So, so basically what I will have, minus 1 to the power n square. Correct hai ji? And then this to this goes cancel out, and basically square root of 2 to the power n. Yes, correct hai? This I will have, and it is nothing but geometric series. It is an alternating series, na? Basically it is an alternating series. Correct hai? So this series, yes, this series is going to be convergent, na? Yes, I can write this series in the following manner. Like instead of n square, I can take minus 1 upon square root of 2 to the power n. Yes, ये लिख सकती हूँ. And clearly this series is convergent. ठीक है? And this will converge absolutely also. है ना? Because if you take the modulo series, so modulo series is 1 upon square root of 2 to the power n, which is nothing but convergent. Yes. So at the minus of root 2, my series convergent absolutely. And similarly at x is equal to plus root 2. Also I have series, same series I will have 2 to the square root of 2 to the power n. It's a positive term series, so which is convergent and same as absolutely convergent. Because for a positive term series, the convergent and absolutely convergence is what? Same. सही बात है? Clear to everyone? Anji, this question is clear na? So the thing is, here we are getting what we are getting, exact reason of absolutely convergence is closed interval minus root 2 से plus का root 2, and that going to be same as for exact reason of uniform convergence and no doubt exact reason of convergence, because for a power series the reason of absolutely convergence and convergence going to be same except at the boundary point, but here at both the boundary point my series converge absolutely, so no doubt reason of convergence, absolutely convergence, uniform convergence, both will be same. Clear? Hanji, clear to everyone? चलिए. Okay, so there is a reason why I am taking this question. I hope आप लोगों को पता हो, नहीं पता हो तो I want to discuss it again. I am asking find R. Okay, find R for this series. अच्छा, okay. So to find the r, to find the radius, which formula you want to apply here? Hanji, which formula you want to apply here? See, chalo, just a second. See, we have taken a result root. Okay, Aniket, very good, beta. Okay. चलो, ओके. सो एक्चुअली मेरा इस क्वेश्चन को बताने का रीजन ये था, सी वी हैव टेकन ए रिजल्ट, है ना, कि लाइक इफ आई हैव ए एन एक्स माइनस एक्स नॉट टू द पावर की एन, ठीक है, देन द रेडियस ऑफ कन्वर्जेंस, सपोज इट इफ आई एम कंसिडरिंग ए सीरीज ए एन एक्स माइनस एक्स नॉट टू द पावर एन एंड रेडियस ऑफ कन्वर्जेंस ऑफ दिस पावर सीरीज इज आर, ठीक है, देन रेडियस ऑफ कन्वर्जेंस ऑफ दिस पावर सीरीज विल बी आर टू द पावर 1 by k. रिमेंबर दिस रिजल्ट वी हैव टेकन ना, ये रिजल्ट हम लोगों ने लिया था. बट बेटा दिस रिजल्ट विल वर्क व्हेनेवर यू आर फाइंडिंग रेडियस, बाय यूजिंग रेशियोज फॉर्मूला. But if you are doing by the root formula, then no need to take this power. Getting my point? तो ये जो रिजल्ट है, ये रिजल्ट हम लोग, this result will work whenever we are finding our radius by using ratios formula in such kind of power series. But if you are applying root formula, then no need to take this kth root again. Clear to everyone, I hope. ठीक है. So if you are finding here radius by this formula to the power 1 upon 3, and because I am using here this term, so obviously बात है, यहां से मुझे क्या मिल जाएगी, फाइनल रेडियस. I will get here final radius. चलो, ओके. सो नाउ तो बस ठीक है, तो वो समझ में आ चुका. इट इज नथिंग बट 4/3 to the power 3n upon 3n. So I'll just have here 3/4. Correct है? Radius is nothing but 3/4. Yes. And reason will be what? Reason क्या होगा? What will be the reason then? Reason क्या होगा? Mod of x is less than clearly 3/4. मतलब -3/4 to +3/4. Then clearly we can check at the boundary point. चलिए, ओके. Let's take just one more question. Say I am having here 2n factorial x raised to n upon 4 raised to n into n factorial. ठीक है. n varying from 0 to infinity. Okay, Pratiksha, really? Chalo. So we will find here R and exact reason. So here as I am getting x raised to n, so to get the radius, we'll use the ratios formula, है ना? We'll use the ratios formula here. So R equal to limit n tending to infinity mod of an upon mod of an plus 1, that is limit n tending to infinity 2n factorial upon 4 raised to n into n factorial, and then 2n plus 2 factorial 4 to the power n plus 1 into n plus 1 factorial. ठीक है. So limit n tending to infinity. So here 2n to 2n factorial goes cancel out. So you just have 2n plus 2 into 2n plus 1. Correct है जी? Okay. 4 to the power n to 4 to the power n goes cancel out. I'll just have n in the numerator. Okay. N factorial to n factorial cancel out. I'll just have, but I'm getting 0. Hanji? Pratiksha, you were saying 1, but we are getting here 0. So do not ठीक है. So इतना जल्दी भी मत करो. Don't be in so hurry बेटा. चलिए जी. Anyway, sorry बच्चा. हाँ, sorry. So radius is 0 here. Basically radius is 0. As radius is 0, so this will, so as here r is equal to 0, so this will imply series is convergent only at its center. Series is convergent only at its center. केवल सीरीज अपने सेंटर पर ही कन्वर्जेंट है. ठीक है, चलिए. ओके देन. तो यस, पावर सीरीज ऑलमोस्ट कंप्लीट है. ठीक है जी, चलिए. ओके, सो लेट्स मूव टू फंक्शंस. फंक्शंस की तरफ मूव करते हैं. ठीक है, फंक्शंस और बेस्ड क्वेश्चंस लेते हैं. तो फंक्शंस का स्टार्टिंग मैंने आप लोगों को पढ़ाया ही था. एक सेकेंड, I need to take some questions from this. चलो, let's leave. प्रांशु सिंह, चैट बॉक्स को कोल्ड हो गया है. अच्छा, इवन ऑड वाले क्वेश्चंस. हाँ बेटा, फंक्शंस में जो भी हम लोगों ने देखा था, लाइक स्टार्ट विद द फंक्शन, इट्स डोमेन, इट्स रेंज, इवन ऑड फंक्शंस, टाइप ऑफ फंक्शंस भी था हमारा, एंड रूट ऑफ सम ट्रांसेंडेंटल इक्वेशंस, एंड वन फंक्शन, ओन टू फंक्शन, इंक्रीजिंग डिक्रीजिंग फंक्शन, है ना? करेक्ट ना? इनवर्स फंक्शन, सब पर, इन सब पर बेस्ड क्वेश्चन लेंगे. खुशबू मैम, प्लीज टेल द टाइप ऑफ डिसकंटिन्यूटीज. So while Khushbu beta, today we are going to discuss problems on the functions. ठीक है, continuities, limits वो हम लोग next class में लेंगे. Well, discontinuities, you are asking a simple question. Type of discontinuity. So basically we have 4 kind of discontinuities beta. We have, Khushbu फटाफट से सुन लो, we have 4 kind of discontinuities. Discontinuity of first kind where both the limits finitely exist but not equal. So it is a discontinuity of first kind. Second, removable discontinuity. Removable discontinuity where both the limits, left hand limit, right hand limit, both are finitely exist and equal, but not equal to value of function. ठीक है. So if we redefined our function at a particular point, जिस point पर लिमिट निकाल रहे हैं, उस point पर अगर हम लोग फंक्शन को रीडिफाइन कर देंगे, so the discontinuity has been removed. So that's why that second kind is known as a removable discontinuity, where both the limits finitely exist and equal but not equal to value of function. Then we have third, which is the discontinuity of second kind. So in the discontinuity of second kind, only one limit finitely exists while the another limit will not exist. And last is mixed discontinuity. In the mixed discontinuity, none of the limit going to be exist. Neither left hand limit nor right hand limit going to be exist. Exist ही नहीं करेगी means either you will have you will get infinite value of limit या फिर you will have no limit. ठीक है, क्लियर है खुशबू? चलो ओके, चलो तो अभी स्टार्ट करते हैं अपना क्वेश्चंस. क्विकली सॉल्व करो इस क्वेश्चन को. लेट a and b a sequence of real numbers. ठीक है, then which of the following is true? Which of the following is true? Only one option will be true here. First time, if an converges, then this will imply an to the power 4 convergence. ठीक है. B option, if mod of an convergent, तो ये imply कर देगा कि mod of an square convergent. C option, if the series an divergent, तो ये imply करेगा series an cube is also divergent. And the D option, if your modulo series an divergent, so this implies that the series an square is also divergent. Pick the correct statement, pick the true statement among them. ठीक है, चलिए ओके. How will you do this question by the way? by option discard method. That means you have to pick counter example. Counter example simple रहेगा. In the counter examples you can take P series है ना, hyperharmonic series, geometric series, like simple series. ठीक है, किसी ने सॉल्व किया? Have you got the answer? Not yet? Okay, who's answering by the way? Confused between A and B. Okay, ठीक है. See, as I told you, whenever we have such kind of questions, see, we can apply our simple test also, ratio and root test, but यहाँ पर उसका नीड नहीं है. ठीक है, so simple से example consider करो. an is convergent, then a to the power 4 is also convergent. बेटा, I can take an as series minus 1 raised to n upon n to the power 1 by 4. I can take this series. It is what? An alternating series. And when you apply here Leibniz test, this series is convergent. When you apply here Leibniz, this series is convergent. But if you take here this nth term to the power 4, then you will have what? 1 upon n. This series is divergent, not convergent. So the A option is not true. A option is not. Oh no, Shivani. Beta, do one thing. मतलब always remember, by considering counter example, we can only discard options. So if we are dealing with MCQs and I can discard 3 options. By taking counter examples. So the remaining is true. Obviously remaining is true. So no need to prove it. तो उसको प्रूव करने की जरूरत नहीं है. अदरवाइज ट्रू स्टेटमेंट को ऑलवेज बेटा प्रूव करना होता है. वी हैव टू प्रूव ट्रू स्टेटमेंट ऑलवेज, बट एग्जाम में इतना टाइम होता नहीं है. सो दैट्स व्हाई ऑप्शन डिस्कार्ड मेथड इज वन ऑफ द बेस्ट मेथड. चलिए ओके, सो ये ट्रू हो गया. बी पे नहीं जा रहा, सी की बात करते हैं. ए एन इज डाइवर्जेंट, देन ए एन क्यूब गोइंग टू बी डाइवर्जेंट. क्लियरली नॉट ट्रू है ना, बिकॉज आई कैन टेक 1 by n सीरीज विच इज डाइवर्जेंट. But if I am taking its cube, that is 1 by n cube, हमें मिल जाएगा. This is convergent. So C is incorrect. If absolute series is divergent, then this is divergent. C, I can take for the D option series, I can take minus 1 to the power n upon n. ठीक है. So if I am taking here modulus, then this series is divergent. ठीक है. But if I am taking मतलब second square of this term, then I will have 1 by n square, which is convergent. Clear है? Clear to everyone? So yes, so this is also incorrect. So the thing is only B option is correct here. So this is how you have to solve such problems. Okay, so we are having, so look, I am taking here problem subjective as well as objectively. ठीक है, don't worry, हमारे एग्जाम में तो केवल objective problems ही आएगी. ओहो, प्रतीक्षा, do you want to ask some questions, beta? Pratiksha, do you have some doubt? Chaliye, okay. So, oh, you sent some questions to Eduncle team. Oh, yes. I got your questions also. Yes, I got your problems also. Give me some time. ठीक है, soon I will solve them. ठीक है प्रतीक्षा? Yes, I got your 3 or 4 problems. Yes. Okay, ठीक है जी. चलिए, so the questions are, we will find here range of the following functions. ठीक है, so we have several methods to find the range. ठीक है, look at, listen. रेंज वाले क्वेश्चन डायरेक्ट नहीं पूछे जाएंगे. क्वेश्चन बेस्ड ऑन रेंज, आई डाउट कि वो डायरेक्टली पूछे जाएंगे. बट द क्वेश्चन जिसमें बाउंडेडनेस पूछा जा रहेगा, ठीक है, द बाउंडेडनेस ऑफ फंक्शन कैन बी आस्क्ड इन योर एग्जामिनेशन. ठीक है, सो वी नो दैट आवर फंक्शन इज बाउंडेड इफ एंड ओनली व्हेनेवर इट्स रेंज इज बाउंडेड. सो टू शो द बाउंडेडनेस ऑफ ए फंक्शन वी नीड टू इवेल्युएट रेंज. करेक्ट ना? तो हमें रेंज आनी चाहिए. चलिए ओके, सो इन द बोथ द क्वेश्चंस वी विल find the range. Okay, so we have several methods to compute the range, है ना. Range by the basic manipulation, है ना. This method we can apply whenever we know the range of basic functions involving in my function, in my rule, given rule. ठीक है, basic manipulation, yes. ठीक है, then we can find out range by the सेकंड मेथड बताया था जिसमें रैशनल फंक्शंस के थ्रू बताया था, देन रिजल्ट पर बेस्ड था एंड सो ऑन. Okay, Pratiksha, very good. But I don't know whether your answer is correct or not. Let's have a look quickly. चलिए फर्स्ट की बात कर रहे हैं. सो एज डोमेन इज एंटायर आर, ठीक है, डोमेन को जरूर ध्यान देना बिकॉज रेंज ऑलवेज डोमेन के लिए मिलता है. रेंज इज नथिंग बट इमेज ऑफ डोमेन, तो डोमेन को ऑलवेज ध्यान रखना. तो cos of x we know lies between -1 to +1 for all x belonging to my domain which is R. So I'm using here basic manipulation method because I know about the cos, that's why. So let's take the negative. So negative will lie in the same range. Negative will lie in the same range, है ना? चलिए, okay. So now add 2. If I'm adding 2, so I will have here 1, 2 minus cos x 3. Okay, then take the reciprocal. Yes, correct, beta. So 1 upon 2 minus cos of x will lies between 1/3 to 1, and it is true for all x. So that's why range of my function f is nothing but closed interval 1/3 to 1, and hence this function is bounded, and hence this function is what? Bounded on overall domain R. ठीक है, चलिए, ओके. लेट्स फाइंड द रेंज ऑफ दिस सेकंड मेथड. ठीक है, ओके. So this second function, and this second function is also defined on overall R. Okay, so but we are having here function of the rational function, basically linear upon quadratic. So here we can apply the second method as well as we can apply here our calculus method also. We can apply here our calculus method also. चलिए, तो हम उसी से करते हैं इसको. Second, I am applying here second method. Let y is equal to x upon 1 plus x square. Okay, okay, let's have a look. फटाफट से देख लेते हैं. y plus yx square minus का x is equal to 0. मतलब चलो ठीक है, is equal to x. The thing is yx square minus का x plus y is equal to 0. Okay, as here my x is real, है ना, domain is entire R. Domain is entire R, that's why this second method will work. Okay, so as see, y in terms of x I am having, so I want x in terms of y now. So x in terms of y we can find by using quadratic formula. So minus का b plus minus square root of b square minus का 4ac divided by twice y. ठीक है, as x is my real, so y never be 0. Y never be 0. यहाँ से हम लोग skip कर देंगे. Okay, as x is real, so this will imply the discriminant 1 minus 4y square should be what? Greater than equal to 0. That means 4y square is less than equal to 1. That means y square is less than equal to 1/4, which is same as mod of y is less than equal to 1/2. Okay, so I am having here y lies between minus 1/2 to plus का 1/2. That means y taking 0 value also. So at this particular point we have to check, do we have a value of x for which the value of y is 0? Yes, yes, correct. X equal to 0, y equal to 0. Yes, correct. So the values of y is this. So values of y will give you what? Range, na? Correct. So this will implies, yes, Pratiksha, your answer was correct. Range of function f is closed interval minus 1/2 to plus का 1/2. Karthik, beta, we are having here y square, है ना, y square. So you have to take square root both the side. Y square is less than equal to 4. That means mod of y will lies between, mod of y is what? Less than equal to 1/2 na. We need to take square root both the side here. ठीक है, okay, so be careful. चलिए, so the thing is this function is also bounded on overall R. This function is also bounded on overall R. Okay जी, चलिए. Let's move to next question. Here is the next question. ठीक है. Which of the given functions is or are even or odd, and which one of them is neither even nor odd. ठीक है जी. Even odd functions के बारे में हमें बताना है. Okay. So first function, even function. If f at minus x will give you f of x, function will be even. If f at minus x is equal to minus of f of x, then function is odd. If अगर इनमें से कोई भी फॉर्म नहीं आ रही है, then function is neither even nor odd. चलिए, first में f at minus x. Okay, so ln of माइनस का x प्लस स्क्वायर रूट ऑफ 1 प्लस माइनस एक्स स्क्वायर दैट इज एक्स स्क्वायर. ठीक है. एंड हियर f of x is what? The same. f of x is given here. ln of x plus square root of 1 plus x square. ठीक है. So as ln of this, so I can take here f at minus x plus f of x. If I am taking, that means if I am taking the addition of this and this, so ln of ab is nothing but ln of a plus ln b. So this can be written this into this, that is minus ka x square plus 1 plus x square. So x square to x square goes cancel out. I am getting ln 1. ln 1 is 0. That means f at minus x plus f of x is equal to 0. मतलब f at minus x is equal to minus ka f of x implies my function f is an odd function. F is what? An odd function. ठीक है. So first one is odd. As okay. The second one ln of 1 minus x upon 1 plus x. Okay. तो second में हमारे पास है f of x is equal to ln of 1 minus x upon 1 plus x. Okay. So if I am taking f at minus x, so I will have ln of 1 plus x upon 1 minus x. Okay. Second one is also odd. F of x is this. Yes. I can just take the negative. I'll just take minus here, minus here. So minus minus will become plus. So this term is nothing but 1 minus x upon 1 plus x. I'll take just reciprocal na. ठीक है. So f at minus x is minus of f of x. That means my function is an odd function. Okay. So second one is odd function. ठीक है जी. Okay. And yes. Third one is it's a cubic equation random with negative sign here. So it is neither not nor even. ठीक है. ये कुछ भी नहीं है. It is none. And what about this? F of x is equal to x times a raised to x plus 1 upon a raised to x minus 1. F of x is equal to x times a raised to x minus 1 upon a raised to x plus का 1 where a is positive. A raised to x plus 1 upon a raised to x minus का 1. Fourth is even. Okay, let's have a look quickly. चलिए. तो f at minus x minus का x a raised to minus x plus 1 upon a raised to minus x minus 1. ठीक है. Let's take the LCM and simplify. Then I'll have 1 plus a raised to x upon 1 minus a raised to x. Correct है. तो take this negative here. So x times a raised to x plus 1 upon a raised to x minus 1, which is nothing but f of x. Yes, so my function is an even function. My function is an Aniket, we are having even beta. We are having even. क्वेश्चन को अच्छे से चेक करो. ठीक है. Yes. चलिए. So this is how we can show even odd functions. चलिए. Next. Here we need to find domain as well as range. ठीक है. Domain and range we need to find. Okay. ठीक है जी. चलिए. So for domain, square root of this. So this argument should be what? Strictly greater than 0 because I'm in denominator. So I want 2x square minus ka 4x plus 3 should be strictly greater than 0 because it's in denominator. See, when you factorize, so quadratic factors to आएंगे नहीं. So as it is a quadratic equation, so if you are taking here discriminant, तो discriminant क्या आ रहा है? b square minus 4a and c. That means 16 minus 24, that is minus ka 8, which is less than 0. Discriminant is less than 0, and here coefficient of x square is equal to what? 2, which is greater than 0. So this will implies this quadratic expression 2x square minus ka 4x plus 3 is strictly greater than 0 for all x belonging to R. Yes or no? I gave you a result on the quadratic expression. If you have a quadratic expression whose discriminant is greater than 0, then based on the coefficient of x square, based on the coefficient of x square, you can say, you can easily tell that whether you can easily tell that your equation quadratic expression is greater than 0 or less than 0. If coefficient of x square is positive, then quadratic expression going to be positive for all x in R. And if your coefficient of x square is negative, then the quadratic expression is less than 0 for all x in R. Correct na? ठीक है, चलिए. So as my this term is positive for all x in R, so this will implies domain of the function is overall R. That means entire minus infinity to positive infinity. ठीक है. So my function is defining on R2. Now I need to find here range. Achha, okay. Okay. Can anybody suggest me the method to compute the range? Method to compute the range. रेंज फाइंड करने के लिए यहाँ पर कौन सा मेथड अप्लाई करोगे? विच मेथड यू वांट टू अप्लाई हियर टू कंप्यूट द रेंज? चलो, you guys are not giving me any, so I am applying here calculus method. I am applying here calculus method. See quickly that as my domain is overall R and this function is everywhere defined, that means clearly you can say this function is continuous. So function defined on R and everywhere this function is continuous. Now we know continuity very well ना? अब हमें अच्छे से पता है continuity. So I am applying here calculus method. श्याम रेडी बेटा, we can apply the second also. हम second भी apply कर सकते हैं, but I am applying calculus method. ठीक है, calculus मतलब by taking derivative and the thing is range find कर रहे हैं हम by maximum minimum values. क्योंकि अब तो हमें सब कुछ पता है, हाउ टू फाइंड मैक्सिमम मिनिमम एंड ऑल. सो आई एम टेकिंग हियर डेरिवेटिव so that I can get an idea where my function attained its maximum value and where my function attained its minimum value. If function defined on a domain and function is continuous on the domain, then range is nothing but either open or closed interval where first point is the minimum value of function, या infimum बोल सकते हो, infimum of function, and second point of the domain is what? Supremum या फिर maximum value of the function. Remember है ना, याद है ना सबको result? If f is defined on the domain D2 say R or a subset of R and f is continuous on the domain D, so this will implies range of f is equal to either open or closed interval. First point going to be minimum value of f over the domain D and second point maximum value of f over the domain D. If function attain its maximum or minimum value, then you will put the close bracket. If function do not attain its maximum or minimum value, in that case minimum going to be infimum and maximum going to be supremum, then you need to put here open bracket. Clear to everyone? है ना, हम लोगों ने लिया था ना ये रिजल्ट? Yes? Okay, Jinesh saying एक सेकेंड, he's asking something. मैम आपको उनमें से जो भी क्वेश्चन आपको सही लगे वही आप बताइएगा, ये कहना था हमें वो क्वेश्चन बैंक डिप्स एकेडमी की रियल एनालिसिस. हाँ बेटा, वो मुझे पता है, वो डिप्स के क्वेश्चन है. चलो ठीक है, आई विल ट्राई टू सॉल्व देम. ठीक है, ठीक है जी, ये रिजल्ट पता है भाई सभी को, है ना? तो बस यही रिजल्ट हम मैं अप्लाई करना चाह रही हूँ. चलिए जी, सो मैक्सिमम मिनिमा के लिए एफ डैश बेटर है हमारा, तो डेरिवेटिव क्या आ जाएगा यहाँ पर? माइनस का 2 तो बाहर है, 2 टाइम 2x स्क्वायर माइनस का 4x प्लस 3 to the power 3/2 and here you will have 4x minus का 4. Okay, so 2 to 2 goes cancel out, so minus का 4, I am taking x minus 1 divided by x square 2x square minus का 4x plus का 3 to the power 3/2. अच्छा, look at it here. This denominator function never going to be 0 as we have already seen. ठीक है जी, okay. So the f dash going to be 0 at the point x is equal to 1. So I have only one critical point and my domain is overall R, मतलब minus infinity से plus infinity. So the critical point is 1. So when x is less than 1, then I will have what? Positive, है ना? When x is greater than 1, then I will have negative. So the point 1 is nothing but point of maxima. Point of maxima. So I am having only one critical point which is going to be point of maxima. ठीक है, विच गोइंग टू बी पॉइंट ऑफ मैक्सिमा. सो ऑब्वियसली बात है, दिस गोइंग टू बी पॉइंट ऑफ ग्लोबल मैक्सिमा. दिस गोइंग टू बी पॉइंट ऑफ ग्लोबल मैक्सिमा. रीजन, बिकॉज आई एम हैविंग ओनली वन पॉइंट. ठीक है, चलो एक सेकेंड. One critical point. Here I am getting negative derivative and here I am getting positive. So in this portion, minus infinity to 1, function will increase, sorry. And 1 to infinity, function will decrease. ठीक है, minus infinity to 1, function will increase. And 1 to infinity, function will decrease. ठीक है जी. Okay, and this is the point of maxima. अच्छा, okay. So here function increase, here function decrease. So just check the value of function at the plus minus infinity na, when x tending to plus infinity or minus infinity. Then f tending to what? F tending to where? कहां पर अप्रोच करेगा? यहाँ पर देखो, आप एक्स स्क्वायर को कॉमन ले लो तो क्या मिलेगा? 2 माइनस 4/x plus 3/x square to the square root. So when you send your x to infinity or plus infinity, denominator is always plus infinity. Denominator is always plus infinity. So 2 upon infinity will give you 0. So function will tends to 0. So getting my point? Function is continuous. ठीक है? We are having only one critical point, which is a point of maxima. When I am finding the value of function at the extreme point, that is at plus minus infinity. मतलब when x tends to plus infinity or x tends to minus infinity, then I am getting function approaching to 0. So that's why this maxima is nothing but global maxima. So चलो find कर लो f at 1. क्या आ रहा है f at 1? 2 divided by 1. Square root of 1, that is 2. So at 1 I am getting just 0.2 and function is continuous now. So increasing like, and here my function is decreasing like. So kind of as a function का क्या रहेगा? Graph. So this is how we can draw the graph. This is how we can draw the graph. Clear to everyone? हाँ जी. Like that. I'm not saying that my function is symmetric. I'm not saying the function is symmetric about the line x is equal to 1. No. Like shape look like it. ऐसी कुछ shape रहेगी. Symmetric नहीं है मेरा function. ठीक है? Clear है? So clearly यहाँ पर range क्या जाएगी? Range of f is equal to infimum is 0 here and maximum is 2. So that's why I will put here closed and I will put here 0 because 0 is the infimum value while 2 is the maximum as well as supremum value. Yes or no? Here infimum of f is 0 and supremum of f is equal to 2, which is same as maximum of f, but this is not equal to minimum of f. See, we have discussed many points in this question. काफी points हम लोगों ने इस question में discuss कर लिया है. समझ में आया या नहीं आया? हमने केवल रेंज ही नहीं फाइंड किया यहाँ पर. We have drawn the graph of function. We have find out the infimum, supremum values, function attending maximum, not attending minimum, and range. Well, range is a bounded set, then I can say that function is bounded. Anyone who want to ask anything? Pratiksha saying, ma'am, can we solve it by squaring both sides? Yes, beta, we can do it. We can do it by this method also. By the second method. Yes, but आप लोगों ने respond किया नहीं, that's why मैंने यहाँ पर calculus method apply कर दिया. Yes, you guys can do it by squaring both the side also. मतलब by using the second method. You guys can do it by the second method also. We can do it by second method also. Second method, that means you can take the square both the side. That means you have to consider let y is equal to 2 upon square root of 2x square minus क्या था 2x square minus 4x plus 3. minus 4x plus 3. Take the square both the sides. So y square is equal to 2 upon 2x square minus का 4x plus का 3. ठीक है. Y in terms of x, I want x in terms of y. So take the cross multiplication. So 2y square x square minus का 4y square x plus का 3y square and minus का 2 is equal to 0. Kartik, 4 wait. Oh, thank you beta, thank you. Yes. Okay, thank you beta. चलिए फटाफट से देख लेते हैं बाय द सेकंड मेथड. चलिए ओके. सो एज इट इज अ क्वाड्रेटिक इन x, सो x इज इक्वल टू माइनस का b, इट इज माई c. ठीक है, माइनस का b दैट इज 4y square plus minus square root of b square, that is 16y to the power 4 minus 4ac. 4a is what? 2y square and c is what? 3y square minus का 4 divided by twice a. The coefficient of x square is 2y square. Okay. चलिए. Okay, so what I'll do? Do one thing. Take 4 outside. ठीक है, 4 outside करो और ये 2 cancel out कर दो. तो यहाँ से 2y square plus or minus square root of, I am taking 4 outside ना, तो यहाँ पर 4y raised to 4. ठीक है, माइनस 4 बाहर निकाल चुकी हूँ मैं, तो यहाँ पर 4 हो गया था. ठीक है, यहाँ पर 2 और ये 2 कैंसिल आउट हो गया. समझ गए ना? तो ये 2y स्क्वायर है, तो यहाँ पर ये हो जा रहा है माइनस का 6y raised to 4. ओके, एंड माइनस माइनस विल बिकम प्लस 8y स्क्वायर. सही बात है. 4y raised to 4 माइनस का 6y raised to 4 प्लस का 8y स्क्वायर अपॉन 2y स्क्वायर. ओके जी. सो 2y square plus or minus the square root of what I am getting 8y square minus of 2y raised to 4 upon 2y square. So without loss of generating, my y not is equal to 0. ठीक है जी. Okay. So as my x is real, है ना, x axis real, so discriminant should be greater than 0. ठीक है जी. That means 8y square minus 2y raised to 4 should be greater than or equal to 0. ठीक है जी. So I am taking here 8, not 8y. I cannot take 8y outside. I can take 4y square outside. Then I'll have here what? I will have 4 minus y square is greater than or equal to 0. ठीक है जी. अच्छा. So this term is already positive. This term is already positive. So I want 4 minus y square should be greater than equal to 0. So this will imply that what? Y square is less than equal to 4. So this will implies mod of y is less than equal to 2. Correct? Huh? So here I am getting y belonging to minus 2 to plus 2. But the thing is, as we have taken square both the side while computing this. ठीक है? So we have to be careful. See, look at here. Clearly here y is positive for all x. Y is positive for all x ना. स्क्वायर लिया तो नेगेटिव पॉजिटिव दोनों वैल्यूज ही कंसीडर होगी. बट हियर माय y is positive for all x. So just a second ना. So as y is strictly greater than 0 for all x belonging to R. So this will implies यहाँ से मेरा जो y रहेगा वो ओपन 0 से 2 ही रहेगा. करेक्ट ना? As here y is not equal to 0, and here also clearly there is no value of x. There is no value of x for which the value of y is 0. Y is 0 when only x tending to plus infinity or minus infinity. अगर x प्लस इंफिनिटी या माइनस इंफिनिटी को टेंड नहीं करेगा तो उसके अलावा किसी भी पॉइंट पर y का वैल्यू 0 नहीं होगा. So yes, clearly y equal to 0 will not be in my range. So values of y's are nothing but open interval 0 to plus infinity, and it is nothing but range of my function f. and as range is this, so clearly infimum of f is equal to 0, supremum of f is equal to 2. As we are getting close interval, so this is going to be global maximum value of f, and you can say your f is bounded. Clear to everyone? ठीक है, तो चलिए जी नेक्स्ट क्वेश्चन पे चलते हैं। फिर ये रहा हमारा नेक्स्ट क्वेश्चन। चलिए, which of the following function has a unique inverse? Okay, which of the following function has a unique inverse? Okay, so for the inverse function, my function should be first of all my function should be 1 to 1. If my function is 1 1 on the respective domain, then we can restrict our codomain as range. We can restrict our codomain as range, so that my function will become 1 to 1 and on to, that is inverse going to be exist. Clear है ना? ऐसे किया था। सबसे पहले to define the inverse, your function defined from A to B, where function should be 1 1 on this function. Function should be 1 1 on this domain. If your function is 1 1, then you can restrict your codomain to range. कोडोमेन को कहां तक रेस्ट्रिक्ट कर दोगे? रेंज तक रेस्ट्रिक्ट कर दोगे। तो उस केस में हमारा फंक्शन 1 1 एंड ऑन टू दोनों हो जाएगा, मतलब इनवर्स विल एग्जिस्ट, यूनिक इनवर्स विल एग्जिस्ट। ठीक है ना? चलिए, तो सिंस यहाँ पर हमारे पास डोमेन गिवन है, सो वी नीड टू चेक फॉर द 1 to 1. If my function is 1 to 1, then I can talk about inverse function, otherwise not. So first of all, function should be 1 to 1. चलिए, तो फर्स्ट फंक्शन वी आर हैविंग हियर 4 फंक्शन। सो फर्स्ट फंक्शन की बात करते हैं। सो डज माय फर्स्ट फंक्शन इज 1 to 1? 1 to 1 के लिए काफी सारे मेथड थे, ग्राफिकल मेथड है, कैलकुलस मेथड है, डेफिनेशन वाला मेथड है। बट whenever my function is piecewise, then best method to show 1 to 1 is what? ग्राफिकल मेथड, है ना? पीसवाइज फंक्शन होता है तो 1 to 1 शो करने के लिए बेस्ट मेथड होता है हमारा ग्राफिकल मेथड। सो वी कैन ड्रॉ द ग्राफ। चलिए, so -5 से -5 is here. So -5 पर क्लोज्ड है, 0 पर भी क्लोज्ड है, -5 to 0 function defining by sin x. So somewhere here, wait, like this, correct है? फिर at 0, between 0 to 1 it is 2, and till 1 it is 2. ठीक है? Okay, then 1 to 4 at 1, if you are putting, look at it at 1, when x tending to 1, that this will tends to what? +1 plus infinity ना, because at 1 right hand limit की बात करनी होगी। So yes, this will tends to plus infinity. Okay, until 2 3 4 and 4, when you put here x is equal to 4, तो 4 पर 1/3। ओहो, इनफैक्ट ड्रॉ करने की जरूरत ही नहीं है आगे, तो अब तो नीड ही नहीं है ना ड्रॉ करने की, बट फिर भी मैं ऐसे ड्रॉ कर दे रही हूँ। तो लाइक फंक्शन का ग्राफ ऐसे कुछ रहेगा, जस्ट ऐसे ही ड्रॉ कर रही हूँ। ठीक है? से हियर 3 पुट करने पर 1/2, 3 पुट करने पर ये 1/2 आ रहा है, लाइक दैट, इस तरीके से ग्राफ रहेगा। जस्ट ऐसे ही ग्राफ ड्रॉ कर दिया। ऑल्दो वैसे ही क्लियर है, माय फंक्शन इज नॉट 1 1 बिकॉज ऑफ दिस डेफिनेशन। There are infinitely many points between 0 to 1. Those are distinct, but having same image as 2. So because this definition, my function f is not 1 to 1. As function is not 1 to 1 on the given domain, that's why we cannot talk about here invertibility of function. है ना? That's why we cannot talk about here invertibility of function. चलिए, but the graph look like it. चलिए, okay. Let's talk about the second function. Second function, does this function going to be 1 to 1? When x is greater than 0, it is -2. Okay, same minus का 1 और minus का 2. Function greater than 0. Because of this, see, क्या questions? Because of this, all the points are distinct, but every point having same image. Every point having same image. So clearly, function is not 1, 1. बेसिकली अगर किसी पर्टिकुलर डोमेन में किसी पर्टिकुलर इंटरवल में अगर फंक्शन डिफाइंड बाय अ कांस्टेंट, so constant function never going to be 1 to 1, and hence my entire function will not 1 to 1, not 1 to 1 है ना, because of this not 1 to 1. ठीक है. So for the first function and second function we cannot talk about inverse function at all because my function is not 1 to 1. If function is 1 to 1, then we can talk about inverse function है ना, by adjusting our codomain. चलिए, ओके. व्हाट अबाउट द थर्ड? ओके, थर्ड का आंसर दो मुझे फटाफट से. डज थर्ड वन विल बी 1 to 1? डज थर्ड वन विल बी 1 to 1? One to one. Okay. मनोज सेइंग नो. वेरी गुड मनोज. प्रतीक्षा सेइंग 1 to 1. देखो बेटा, थर्ड को देखो. थर्ड में क्या आ रहा है हमारे पास? f of x is equal to x plus x square to the square root. So please always remember, always, whatever you have your argument, that is square to the square root. If you have this, so always write this thing is equal to mod of fx. Unless if you know your argument is positive, then only you can remove the mod. Otherwise, always simplify it in this manner. बताया था आई गेस मैंने आप लोगों को. नहीं बताया था तो प्लीज ध्यान रखना. ऑलवेज. तो यहां पर एज आई डोंट नो व्हाट इज माय एक्स, बिकॉज डोमेन क्या दिया हुआ? ओवरऑल आर. तो माय एक्स कैन बी पॉजिटिव, माय एक्स कैन बी नेगेटिव. सो एक्स प्लस दिस इज नथिंग बट mod of x. X can be positive, x can be negative, na? That's why I will write it like this. So if my x is greater than or equal to 0, I will have twice x. But if my x is less than 0, this will be minus x, so I will have 0. So here for the infinitely many points, image is same. So this will implies f not 1 to 1. Clear है? So third one is not 1 to 1, that's why not invertible. What about the fourth one? F of x is equal to 2x upon 1 plus x square. F of x is equal to 2x upon 1 plus x square, and domain is overall R. So my function is continuous now here. Here my function is continuous. It is defined everywhere on R. So for the 1 1, I am using a calculus method, है ना? मतलब strictly increasing, strictly decreasing. So function going to be 1 1, otherwise not. So let's take the derivative. So f dash x 1 plus x square to the whole square, keeping 1 plus x square as it is, and taking derivative of twice x, which is this, minus keeping this as it is, and I am getting twice x. So 2 plus 2x square minus का 4x square divided by 1 plus x square to the whole square. Okay, so 2 minus 2x square upon 1 plus x square to the whole square. Simply 2 times 1 minus x, 1 plus x. So look at here. My function is not increasing or decreasing on overall R. That's why my function is not 1 to 1. Yes. Algebraic method. But this calculus method is quite easy, beta. Okay. So I am getting this. If you want to draw the graph, then let's have a look quickly. So critical points are +1 or -1. Say it is your +1. Here is your +1. Here is your -1. ठीक है जी. Okay, so when x is less than -1, so this will be positive, this will be negative, so I'll have here negative, here I will have positive, and here I will have negative. So this is going to be point of local minima, this is going to be point of local maxima. Let's keep them local, but local ये मिनिमा हो रहा है और ये हमारा मैक्सिमा हो रहा है. ठीक है जी. अच्छा, ओके. सो एट द जीरो फंक्शन इज जीरो एंड पॉजिटिव है इस इंटरवल में, तो फंक्शन इंक्रीज करेगा. सी द वैल्यू एट -1 क्या आ रहा है, -1 पर वैल्यू कितना मिल जा रहा है हमें, -1. -1 पर -1 वैल्यू है. ओके, एंड +1 पर +1 वैल्यू है. सो फंक्शन ग्राफ शुड बी लाइक दिस. ठीक है. ओके, एंड व्हेन माय x टेंड्स टू पॉजिटिव इंफिनिटी, दिस विल टेंड्स टू 0. तो एंड ऑल्सो नेगेटिव है डेरिवेटिव, तो फंक्शन डिक्रीज ही कर रहा है. ठीक है. Here derivative is also negative, function will decrease, and x tending to minus infinity, then also this will tends to 0. Graph will going like that. ठीक है. Clear है? So we can draw the graph also. Clear to everyone? ठीक है. Suppose it there will be a question in your examination. Suppose करो कि in the fourth one f of x is equal to k given है. f of x is this and equal to k given है, and you need to find the value of k for which the equation, this equation has 1 root, 2 root, 3 root, like that. ठीक है. I am asking find the value of k for which the above equation will have two distinct positive roots. Getting my point? I am asking new question. Say 4 star. ठीक है. f of x is this. Graphical approach we know ना, to find the number of solutions. Okay. F of x is, if I am taking f of x is equal to k, then I am asking the question, find the value of k for which the above equation, this equation will have two distinct positive roots, that is positive solutions. ग्राफ आपके सामने है. Can you give me the answer? And we have done, I guess, similar question. Yes, हमने किया था, जो कि जैम में ही आया हुआ था. And I have constructed similar question like that question. कोई बताएगा मुझे k की वैल्यूज क्या क्या हो सकती है? Can you give me a range for the k values? Suppose that I am giving you some options. Okay, who's answering? Manoj, very good beta, very good. K can be any number in the open interval 0 to 1. K can be any number in the open interval 0 to 1. ठीक है. Because when your k lies between 0 to 1, ठीक है, then you need to draw the graph of this k ना. तो इसके लिए कोई भी लाइन रहेगी इस तरीके की रहेगी. Correct? So it will cut your graph at 2 points. और ठीक है. करेक्ट है. बिकॉज आई एम आस्किंग फॉर द पॉजिटिव वैल्यूज. और जस्ट अगर पॉजिटिव वर्ड नहीं होता, देन k कैन बी, अगर इफ आई एम नॉट यूजिंग दिस पॉजिटिव वर्ड, देन k कैन बी एनी नंबर बिटवीन -1 to 1, but you have to exclude 0. है ना. because if k equal to 0, then it will cut your graph only at 1 point. Yes or no? आया समझ में सभी को क्वेश्चन भाई? Anyone, any doubt? If have any doubt, please ask your doubt. Otherwise, I'll take another question. ठीक है, फिर आगे बढ़े. चलो, ओके then. Oh, wait. I'm having this question. F of x is this, x in overall R. Does f is invertible? If yes, then we'll find the rule for f inverse. ठीक है जी. So I'm having this function. Okay. So we can redefine it, because first of all we need to check the 1 injectivity of function on defined domain R. चलिए, तो ये जो है वो हमारा 1 और -1 के लोग चेंज होगा. x is less than -1. 2 or -1. Okay. When x is less than -1, less than minus का 1, so this will be negative. So minus of 2 times x minus 2. Minus will become plus x plus 1 plus का x. So what I am getting, minus का twice x plus का 4 plus का x plus का 1 plus का x. So x to x goes cancel and I am getting 5. Okay. This function is 1 to 1. This function is 1 to 1. 1 to 1 होगा अभी. So minus का 2x plus का 3 and both are positive. So twice x minus का 4 minus का x minus का 1 plus का x. So I will have that 3x. No, x to x goes cancel out. Twice x. Oh, just a second. Plus x, okay. So here x to x goes cancel out and minus का. Oh, minus का 5 would be there. ठीक है, yes. Not 1 ना. 5 minus x will be there in first interval. 1 second. 5 minus x will be there. Just a second, beta. 1 second. Do I made mistake क्या? नहीं बेटा, 5 minus x क्यों आएगा? X to x goes cancel out ना completely. So 4 plus 1 will give you 5 only. Okay na? Because x is also there. So I am getting this when x is greater than equal to 2. Okay. So because of this constant term, whenever x is less than -1, function defined by the constant 5. So because of this term, my function is not 1 to 1. Clear hai? So my function is not 1 to 1. Chalo, now I am giving you a question. Suppose if I am restricted my domain, if I am restricting my domain as the domain of f, if I am taking say -1 to infinity. If I am taking my domain is this. So now then you guys check, does f is invertible? Okay, I have restricted my domain to -1 to infinity. So now you guys check. Now your function is invertible. If yes, then find out the rule also. Okay, chali, okay. So let's wind up our today's class right now.